continue the sprint. Usually second time you have like even higher score than before.
Wait, are you talking about the Amatic test?
Amatic, right.
Oh.
Amatic competition.
I thought you were talking about the...
It goes by
No,
two
no, no.
names. This is American Mathematical Association of 2-year colleges, which we used to be. So this is actually, you have to be eligible for this. You can't have taken a 3,000 level math course or be enrolled in one. If you're 2,000 level or below. And the other word for it, the other acronym is Student Math League. And I'm not sure how the two gel, but it's prepared and distributed by the American Mathematical Association of 2-year colleges, of which we are a quasi-member, although we are now, as y'all know, part of a 4-year university. You're eligible to participate in this, if I understand right, if you have less than, if you're under the 2,000 level in your coursework in math, and you have no degree from around. Well, I don't even know if it would apply if you had a degree or not. Anyway, that's the rules as I know it. Now this is the date of the actual test. It's free. You don't have to pay anything. You don't have to prepare for it. But I suppose you and I, Dr. B, Bingham, we're going to be giving some sort of preparation, and we haven't decided on times to do that. But we will publish those. If you're interested in it, see Dr. Bingham, or come see me. My name's those of y'all that don't know me. And today it fell upon my turn to actually do a presentation. So
Yeah, the title of our today's presentation is very intriguing. Russian Peasant multiplication.
Russian peasant
We need you
multiplication.
to expand a bit more. Because you've been closest
Yes,
to it.
and Professor Greear asked me, would you kind of like get offended if the title of my presentation got the Russian Peasant multiplication? I thought, no, not at all, okay?
Okay, so we checked to see if this was offensive to anybody, and it's not.
It's not.
Apparently, actually, as I was telling Dr. Danny from my limited amount of research about it, this technique of multiplication is actually throughout the medieval world, at least throughout the Western medieval world. And like I say, the advantage of it is you don't have to know any of your multiplication tables except the twosies. Of course, you need to know like 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7, 2 times 8, 2 times 9, and basically that's all the multiplication tables you have to remember. You don't have to remember the hard ones like 8 times 6, stuff like that. 8 times 7. Well, you just push the button here and Of course, it wouldn't hurt to know your halvesies either. Other great thing about Russian peasant multiplication is that you throw away remainders and don't have to deal with fractions. So we don't like that either. You know, like I say, the apparent counterparts of Russian peasants are American country boys. And as I've noticed over my years of teaching math, they don't like fractions or remainders either. You can get rid of these, make life easy on yourself, everybody's happy, and we do the Russian peasant multiplication. So would y'all like to see how it works?
Oh, yeah.
Can you just touch the screen here? Nope.
Push again.
There, right here.
Ah, yeah, that one, yeah. No?
Well, I don't know how to do
Can you use a remote?
Okay, so we click on this. No, we click on this. Okay. So suppose you want to multiply 38 times 452. So that's your problem. Of course, today we would probably reach for a calculator. Most people would to do that type of multiplication. Or we have algorithms that work for it. Several different algorithms for it. But the way you do it for Russian peasant multiplication is you write the two numbers side by side in two columns. And then you take this row is your halvers, or what your halves, and this row you double. So you take half of 38 and you double 452. That's why you need to know the twosies and the halvesies, right? Okay. You have the numbers in the first row of the first column and double the numbers in the first row of the second column. Now, what did I do? Okay, so nothing's happening. Been food. Okay, I'm not pushing hard enough. Okay. So say for instance, if you took half of 38, what's that? 19. 19. And then what happens when you double 452?
904.
904. Okay. So then suppose you wanted to take half of 19. What's half of 19?
9.5.
8.5 if you were on.
9.5. 0.5.
Oh,
Basically, it would be 9.5, right?
right.
Or 9, and you'd have some sort of remainder when you divide it. If you divide 2 into 19, what happens? Think about that. You get 9, right? And then you got an 18 down here, and a remainder of 1. Well, we throw away the remainder. We're not interested in those numbers. That's hard. But we double the right-hand side. What we get there? 1808. Everybody with me so far? Okay, so half of 9, 4. What have we got? 36, 16 over here. Half of 4 is 2. Double your 16, you got a 32. Double your 6, you got a 12. Double your 3. 7, 2, 3, 2. You got to check my arithmetic because I'm not really great at arithmetic. Finally, you get down here, and at some point or another, this column will always get down to 1, right? And this column over here, this column will continue to grow, and this column will down to 1. So now we double this. We've got a 4, a 6, a 4, and a 14, right? Okay, so you're ready to now go through and look back at the numbers in your left-hand column. So the algorithm continues. You have the numbers in the first row, double the numbers in the first row of the second column, create the second row. When you encounter an odd number to have, you throw away the remainder, that multiplies 50. You throw away the 0.5 or the remainder for the division. After the first row, all the numbers in the second column will be even. Notice that? All of these, even if this had been odd, it'd be even now. So that's all even all of the numbers. Life is good. Now, eventually your halving column goes down to the number 1. Go back through the columns and cross out all rows that have an even number in the halving column. This is where my wife got mad at me. Said I didn't explain it right. So you cross out all the rows in which there's an even number in the halving column. Okay? See any more? Yeah. And that. Okay? The remaining numbers over here in the right-hand column, you add up. You add all the remaining numbers in the doubling column. The result is the product of your original two numbers. So going down through here, 4 plus 8 is 12, plus 4 is 16, right? Got 1 to carry. 1, 7. And then 4 plus 8 is 12, and 9 is 21. 2 to carry. 3, 7, and
17,176. See?
Now that's no problem, they'll actually, look at that. Like, on some of them, like, I know that, like you did, if the halves on one
Column and the double on the other. It'd be different if it was all the way around.
That's a good question, see?
Jay, we're going to address that here in a minute. I thought about the same thing when I was doing it. Now, of course, you know from theory, your arithmetic theory, that perhaps A times B is supposed to be identical to B times A. At least this is true in the field of real numbers, right? Complex numbers.
isn't it still good, micro numbers?
Well, it's not necessarily true in some types. Well, is it true for all possible fields like that? For instance, for matrix algebra, if you get around to studying linear algebra today, as you do someday, you'll discover that commutativity of multiplication is not assumed to be true. It's not true. But now we're talking about something a little bit beyond the immediate.
What's the difference between the identical sign and the equal sign?
Well, this is a little, you don't see this much, but that is occasionally used to show
That you're talking about an identity rather than a conditional equation. So that's why I use a triple part equals mark. Anybody else ever seen that? Or is it just me? Okay, none of the other math professors will do that. You seen that? You seen it? It's occasionally done.
Just wasting.
It's a way of showing that you're talking about an identity. Remember, like an identity, we're going to deal with another identity. X times y equals 1/2 x times 2y. Again, that's not a conditional equation. That should be true for any real number. Okay? So that's an identity. Okay, should we move on? Answer your immediate questions. Of course, what's happening here is I'm putting x's in there to do this. Just do a little crossing out. And in fact, because I didn't trust my arithmetic, I started going to Excel to get Excel to do my Russian peasant multiplication for me. I realized this was not available to the average medieval European peasant, the Excel spreadsheet, but we got them now. All right. So the X's here represent crossing out the rows. Here's a more sophisticated copy of the
Excel spreadsheet set up to do Russian multiplication. This is multiplying 28 times 709. Everybody see that all right? 28 times 709. Notice over here in your halvers column, 28 gets half. 28, 14, 7. Half of 7 is 3. Throw away the remainder. It needs that. Half of 3 is 1. Throw away the extra 1.5. By the way, half of 1 is what? 0. Half of 0 is 0. Half of 0 is 0. So actually, you can continue this process. And 0 is a... Are we getting in a hurry, Boo? Do you think this works? Well, just while you're at it, check to see if 28 times 709 equals 19,852 by whatever algorithm you choose. Dr. Hebda chooses the punch the button on the calculator algorithm, which is very popular. Very popular. That and the cell phone. Somehow the cell phone is able to tell you this. I don't know how. My cell phone will not tell that. Okay. Now, actually, here, notice I've got an extra column here called, does this have a pointer on it, too? No. Does this have a pointer on it? Is that it? Okay. Okay, now I like it already. See, now we've got a column here called keepers. Instead of crossing out numbers, notice I'm putting a 0 there where there's an even number over here. And I'm putting my keepers there to be the numbers that I keep, and that avoids the awkwardness of this addition where you might get confused with your interwoven numbers. This is, if you want to try some Excel programming, this uses the if command and the is even question and the is odd question, the logical labels, is even and is odd. You can look those up. Notice that after a certain point, all the halvers are zeros, and since 0 is even, those all the keepers in that column are 0, because you'd be throwing those numbers away. So you're throwing away, 94,000 something. You're not going to add that in there, are you? No. And of course, that will be zeros from there on down to wherever. So you don't have to worry about that anymore. So let's see what else might happen. How does Russian peasant multiplication work? A couple people have asked that question. Good, I think, how does it work? Before we answer that question, look at what happens when Ivan and Svetlana use Russian peasant multiplication to multiply 1,759 times 1, a problem given to them by their Russian professor. Okay? First, Svetlana's work. In her halvers column, in her halvers column, she puts a 1. And in her double column, she puts a 1759. And so she halves 1, gets down to 0, doubles 1759, has 3518, but she's not going to keep it. And she knows that 0 is an even number, and she's going to have zeros from there